This is AP Calculus ABA, Unit 7, Applications of Derivatives, Lesson 1, Extreme Values of Functions. So we're going to be looking at something called extrema. That is maximum and minima. So extrema come in four flavors. There is a local, local maximum, local minimum. There is a global maximum and a global minimum. The names are pretty straightforward to remember. Local means within a region around a particular value. So it's the lowest, or the local max is the highest point within a region around a point that you specify. A local minimum is the lowest point in a region around which you specify. The global max is the highest point anywhere on the function within the specified domain. The global minimum is the lowest point on the function within the specified domain. And this all comes down to finding something called critical values. Critical values. And those come in two flavors. They come when the derivative is 0, because at that such point the slope, the instantaneous slope, is 0. It's flat. Okay, and if the function is differentiable, that will be typical of a local or a global minimum or maximum. Okay, then there's also where the derivative does not exist. Okay, because those can also be critical values. They can be maximum or minimum. And then, of course, there's a third flavor, the endpoints. If we are in a specified closed domain, it has to be a closed domain. You can't really talk about a maximum or a minimum in an open domain because there is no absolute endpoint. There is no absolute highest point. Okay? All right, so one of those three things, either the derivative is 0 or the derivative does not exist, or we examine the endpoints. So if you're looking for extrema, these are the three things we need to find. Now I have on my screen the function, absolute value of a quadratic, x squared plus 4x minus 10. And we're going to find the local and the global extrema on the closed interval -5 to 5. Okay? Well, first of all, this is an absolute value, and absolute values produce cusps, that is corners, actually. And those are non-differentiable. So that would be anywhere the contents are 0. So let's find that here. So we're going to say x squared plus 4x minus 10 equals 0. Okay, and we're going to find where those extrema happen. Now I can try to factors of 10 are 2 and 5. Their difference is not 4. So this is not going to factor easily. So our roots are negative b plus or minus square root b squared minus 4ac all over 2a. So we get negative 4 plus or minus square root 56 over 2. 56 is 2 times 28, which is 2 times 14, which is 2 times 7. So we could simplify that to that square root to 2 root 14, but that's not really very helpful. I suppose it could be a little bit here. So that equals negative 4 plus or minus 2 root 14 over 2, which is divide and factor out and cancel 2. So we get negative 2 plus or minus root 14. Okay. All right, so the question is, which of those are in the domain from -5 to 5? So let's crunch that on a calculator here. Okay, so -2 plus square root 14, 1.74. -2 minus square root 14 is outside the bound. So -2 plus square root 14 is a critical value. It is a point of a cusp. Okay, and so we need to figure out, so we're going to eliminate the minus, so negative 2 plus square root 14. Okay, and we're going to figure out what the output value is at that point. Well, the output value at that point is 0. Okay, because that's the way we defined it. All right, so now that's one critical value where the derivative does not exist. Okay. All right, so another critical value occurs when the derivative is 0. So f prime of x. Now, since we're setting it equal to 0, we're finding where the slope is 0. And it doesn't matter whether we have the absolute value or not. So the derivative here is going to be 2x plus 4. We're going to set that equal to 0. So 2x equals negative 4, x equals negative 2. Okay, is a critical value. All right, let's find the function value at negative 2. F of negative 2 is the absolute value of negative 2 squared plus 4 times negative 2 minus 10. That's 4 minus 8 minus 10. That's negative 4, negative 14, absolute value is 14. Okay, so negative 2 produces an output of 14. So let's plot this as a point here. Let's set these over on the right here. We have the point negative 2, comma, negative 2 plus square root 14, comma, 0. And we have the point negative 2, comma, 14. Okay, and we also need to check the endpoints. So let's check the endpoints. What is f of, here we go, f of negative 5. F of negative 5 is absolute value of negative, or 25. I'm just going to take a couple of steps here, a couple liberties. Minus 20, minus 10. Okay, minus 30, this is going to be 5. Okay, so that corresponds to the point negative 5, comma 5. Okay, and then let's check the other boundary here, f of positive 5. F of positive 5 is going to be 5 squared is 25 plus 20 minus 10. 25 and 20 is 45, less 10 is 35. Okay, so that corresponds to the point positive 5, 35. Okay, so we have, if we look at these extrema, here's my conclusion. I have a global minimum at negative 2 plus root 14, because its output is 0. I have a global max at 535. And the question remains whether these other two represent global or local, minima or maxima. And to test that, we can test points on either side of them, or in the case of the negative 214, we can check the second derivative, which the lesson doesn't get into yet. But let's verify this using our graphing calculator here. So I have our function, okay, absolute value, x squared, oh come on, absolute value, x squared plus 4x minus 10, close absolute value, okay, from negative 5 inclusive to 5, okay. And so we can see the global minimum here is the 1.742. That was negative 2 plus root 14, 0. And the global max was 535, right? The local, this one here, negative 214, is a local maximum, because it's the highest point around that point. And this point right here, negative 5, 5, is a local minimum because it's the lowest point in that region, but it's not the absolute lowest point on the graph. Okay, so critical values. Derivative equals 0, derivative does not exist, and or endpoints are critical values that need to be checked for extrema questions.